Assalamualaikum and good morning. Alright, so we have limit theorem today. So we have a limit theorem. We have around 6 limit theorem there. Okay, 6 limit theorem. Sorry, 7 and 8. Okay, 8 limit theorem to discover by today. Okay, first of all, we have this. We have limit x approach to see how to pronounce it. It's a limit x approach to c k is a constant there, constant, okay, equal to k. Because of constant we don't have any x to be approached to c, okay, equal to k. Then for example we have limit x approach to 2 4, so automatically we get 4 there. So based on the theorem, first theorem. Okay. Number 2, okay, so this is not a k actually. This is actually the constant or any function lah. Alright. So we have any constant, any numbers, or any variable. Is not variable except x. Right. So number 2, we have theorem limit x approach to c x. So we have one x there. Okay, so automatically the value of limit equal to c because of this approach, right? So this approach x and then this x and x approach to c. So for example, we have limit x approach to 2x. So automatically these two will replace with x. X will replace with 2, right? So theorem number 3, we have combination of the constant and function x and function fx there. So this theorem said that we can move or remove k outside the limit, right? So outside the limit. So for example, we have limit x approach to 2, for example, 2x. So we have 2x the function as the constant there, and x is a function. We can automatically move 2 outside the limit. So limit x approach to 2x. So automatically we get 2. So limit x we continue or use the previous theorem equal to 2. So 2 times 2 equal to 4. Alright. Okay, now we have fourth theorem. The combination or addition of two functions there. We have a function fx plus with the function gx, and how to get the limit. We can separate fx function plus with the function of limit of gx. For example, I have this. Okay, we have limit x approach to 2x square. Sorry, it's not x square. Okay, let's square plus x, for example. Right. So that we can separate it. Then we get x limit x square x approach to 2 plus limit x approach to 2x. So we have two functions there. This is function gx, fx, and this is function gx. So finally we get x squared. So this is x squared. So we can replace or approach 2 into x, then we get 4 or 2 power of 2, then we get 4 plus substitute 2 inside the x, then we get 2, then we get equal to 6. 4 plus 2 equal to 6. Alright. So now we look at function theorem 5, theorem number 5. Okay, it's quite similar with the additional or add function. Okay, additional function. This is subtraction of the function. Okay, so if we have fx minus gx, how to get the limit? So we can separate it. Okay, then we put negative of minus there. Fx minus gx. Alright, so no need the example for that particular theorem. Okay, now we look at the theorem number 6. So we have fx times or multiply with gx. Okay, how to find the limit? We can separate fx and gx there and then multiply inside or in between of the limit. For example, we have limit, same example, x squared times x. Okay, x opposed to 2, same as the previous example. So that we get limit x squared, x opposed to 2 times limit x opposed to 2 x. So that we get limit x squared, so we get 4 there, times limit 2 equal to 2. So that we get 8 here. Right? So the answer equal to 8. Alright, so we can get theorem number 7. Okay, we have x limit fx over gx. Okay, we have this fx over gx, and then we can separate it. So limit fx first, divide by limit gx, x opposed to 6. Then the last theorem should be limit fx opposed to n, limit fx power of n, x opposed to c. So we have function in power of n there. So we can find the limit of fx first. Okay, limit of fx, x opposed to c first. Then after that, we can power with n. Okay, for example, I have this. Limit x minus 1, x opposed to 2, power of 3. So how to get the limit? So first of all, we have to find the limit x opposed to 2, x minus 1 first. Then obviously we can power the limit equal to 3. Right, then we get x opposed to 2, so we get 2 minus 1 power of 3, then we get 1 power of 3, 1. Alright? Alright, so we look at the example of the limit. Okay, we have to use 8 theorem there to find the limit of 2x squared minus 4, x over x minus 2, x opposed to 2. Alright, so I write down the limit in the sketch paper. Solve it. So limit 2 x squared, okay, please look at that, x squared minus 4 over with x minus 2. So x minus 2, then x opposed to 2. X opposed to 2. So how to solve this? By using a theorem previously. Okay, so first of all, we have the division here, divide of the function. So we separate the division. We have limit x opposed to 2 x squared minus 4 first, divide by limit x opposed to 2 x minus 2. Right? Alright, so in here we have 2, which is k, constant, times with the function. Okay, obviously we can separate or move 2 outside the limit. So 2 outside the limit, x opposed to 2, and then this is negative or minus, so we can separate it. Then we get limit x opposed to 2 x squared minus limit x opposed to 2 4. Right? Okay, then divide by limit x opposed to 2 x. Okay, we can separate it, minus limit x opposed to 2. Right? So we separate it there. Okay, so what we have to do now, we have to get the solution of the limit. So we have 2 opposed to power of 2, then we get 4 there, minus, okay, this is a constant, so we put constant there, okay, over limit x opposed to 2x, so we have to substitute 2 inside x, so 2 minus 2 x opposed to 2, so we get 2 there. Okay, please carefully here, because of that, because of we can't solve this. Because of what? Because of this actually we can get 8 minus 4 over 0 there. So if the forbidden in mathematics equal to 0. So you cannot use this step, okay, because of we can end up with the equal zeros, which is a forbidden, and then which is math error in the calculator. Okay, so what we have to do at the beginning, actually, we have to factorize the limit first. Okay, the function first. Okay, we have this limit x approach to 2. 2 we factorize to x minus 2 and x plus 2 over x minus 2. So after this, we have to, okay, divide x squared, x minus 2 over x minus 2, we get 1. So that we get limit x approach to 2, 2 times x plus 2. Right? So actually this is the way you learn, because you make a mistake first, then you look at the way is not suitable for you. Okay, then what we have to do is we have to separate 2 outside. We can move 2 outside the limit so that we have x plus 2 there. So then we get 2. Okay, then separate limit x approach to 2x plus limit x approach to 2. Alright, so that we have 2 limit 2 inside approach x, substitute 2 inside x, then we get 2 plus, okay, so this is a constant, so we can get the constant back, so that we get 4 plus 2, then we get 6 there. Okay, so actually from this particular solution, actually we have to back again from the previous or the first step of the function. We have to remove the denominator of the function. Then we can get the limit of the function. Okay, that's all for today. Hopefully you can understand better in this video. Thank you very much.